Okay, today I wanted to go over some function problems that I found on the NJSLA release items. This is like a type 1 question. Okay, as you can see here, we have which value is a solution of the equation. We have x squared is equal to 2x plus 1. 2x over x plus 1. All right, so the whole goal is to identify how many x values you should be able to solve. All right, in order we can be able to determine that is finding the highest x degree. So what I want to focus on is getting all of these x values on one side of the equation and equal it to 0. Okay, so we're gonna start off with x squared is equal to 2x over x plus 1. Step 1, I will start off with multiply x plus 1 on both sides. Okay, so with that being said, it's going to be x squared times x plus 1 equal to 2x over x plus 1 times x plus 1 on both sides. All right, so my whole goal is to get rid of these x plus 1 on this side. I wanted to cancel that out. All right, so that's why I did that. So I'm going to rewrite this as x squared times x plus 1 is equal to 2x. My next goal is, for step 2, is to get this 2x on the left-hand side of the equation as well. All right, so step 2 is going to be subtract 2x on both sides. Whatever you do to one side of the equation, you have to do this to the other. That's what the equal sign represents. Okay, so you're going to have x squared times x plus 1 is equal to, well, minus 2x is equal to 2x minus 2x. All right, so as you can see here, these are two of the same values. They're going to cancel out. All right, you got 2x minus 2x. So now you have x squared times x plus 1 is equal, oh, not equals, minus 2x is equal to 0. All right, so now that we have this set up like this, now it's going to be much easier for us to find, determine the x values. So step 3, I'm going to distribute the x squared inside of the equation. So you're going to have x squared times x and x squared times x. X squared times 1, I'm sorry. So you're going to have x squared times x, meaning the exponent is going to add, so it's going to be x to the third plus x squared minus 2x is equal to 0. All right, my next step here is going to be to factor out an x value. All right, because each one of these terms have a like terms, which is an x. So I'm going to factor out the x. So that will be step 4, I'm sorry. So you're going to have x times x squared plus x minus 2 is equal to 0. These two outside values, this x and the 0, becomes one x, or factor form that we found, one of the x values. And then you're going to have x squared plus x minus 2 is equal to 0. Okay? So this point here, I'm going to use the factoring method. So we're going to have our a value is going to be 1, our b value is going to be 1, our c value for this one, this factor form is negative 2. So we're going to do the a times c. So we know this is going to be 1, this is negative 2. We have to find two factorable numbers we can multiply and give us negative 2, but also add up to 1. All right, and when I think of it, the two numbers that we can use is 2 and 1. Now you have to determine which number will be negative. The number that will be negative will be 1. Okay, so we know that we have 2 minus 1 is going to equal 1. All right, so if we put this in factor form, it's going to be x plus 2 times x minus 1 is equal to 0. Okay, so now step 5 is to find Alright, so I had to kind of cut short on the video because I was running out of room and place to write. All right, so as you can see here, step 5, I was pretty much trying to write, we have to find x. All right, so to determine the x values, we have to take x plus 2 is equal to 0, and x minus 1 is equal to 0. We had to find the 2 extra x values, all right? So we had to subtract 2 on both sides for the one equation, and we had to add 1 on both sides for the other equation, which gave us x is equal to -2, and also x is equal to 1. And as you can see here, I wrote the x values at the top. We have x is equal to 0, -2, and 1, and also circled the exact values that apply. All right, so if you have any questions, don't hesitate to like, comment, and reshare my video and my photos. Have a good one.